Good day, everybody. Welcome to Solved It. Today, we will be learning about the fundamental counting principle. By the way, this topic is preparatory for us to learn deeper about permutations and combinations. So, we will be doing video tutorials regarding permutations and combinations in the later part. So, what is fundamental counting principle? Fundamental counting principle states that if there are n ways of doing something and m ways of doing another thing, then there are n times m ways to perform both of these actions. Here we have example number 1. Jose, a novice writer, needs to choose a name for his main character of his novel. He can choose among Alpha, Bravo, Charlie, and Delta as first name, while Echo, Foxtrot, Golf, and Hotel as last name. How many possible ways can Jose name his main character? So to start with our solution, so we need to let n, our capital letter N, be equal to the total number of possible ways that Jose can name his main character. So based on the fundamental counting principle stated above, it's represented as m multiplied by n. So what would be m and what would be n? So m here in our problem would be the number of ways we can choose for first name. And how many ways could we choose first name? So we can see 1 Alpha, 2 Bravo, 3 Charlie, 4 Delta. So there are actually 4 ways we could choose for our first name. And how about n? N would be the number of ways we could choose for our last name. And based on the problem, there are 1, 2, 3, and 4 number of choices that we could choose for our last name. So we just simply multiply, and our answer would be 16 ways. Okay, so it's fairly easy. If we would try to list what are the ways that we could name, or Jose could name his main character, these would be the names. 16 names. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so let's have another example for us to understand better about this topic. Here we have example number 2. Elon wants to buy a mansion, an orchard, and an island. He can choose from 10 mansions, 5 orchards, and 3 islands. How many possible ways can Elon buy these luxuries? For our solution, again, we need to let n is equal to the number of possible ways in which Elon can buy these luxuries. Okay, so what are the luxuries here? He needs to buy a mansion. And how many ways can he choose to buy a mansion? So there are 10 ways he could buy a mansion. So we need to put 10 here. And how about an orchard? How many ways can he buy an orchard? Okay, that's 5. So multiplied by 5. And how about an island? There are 3 ways he could buy an island. So multiplication, so that would be 50 times 3. So that would be 150 ways. In which Elon could buy an island, an orchard, and a mansion. Okay, so that's it for the second example. So let's go and solve our third example. In our example number 3, we will employ the fundamental counting principle, and we will let n is equal to the possible ways in which we could form our 4-digit ATM PIN code from numbers 0 to 9. So we have empty slots here. This would be for the first digit, the second digit, the third digit, and the fourth digit of our ATM PIN code. So if we would inspect, numbers involved from 0 to 9 are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers involved. For our first lot or first digit, how many numbers to choose from? Correct. So we can choose from 10 numbers. The numbers from 0 to 9. So we write 10 in here. How about for the second digit of our ATM PIN code? How many numbers to choose from? Note that repetition of digit is allowed. Yes, correct. We still have 10 numbers to choose from. And how about in our third slot? We still have 10 numbers to choose from. And also in our fourth digit, we can choose from the 10 numbers 0 to 9. So simplifying, 10 times 10, we have 100. And 100 times 10 is 1,000. And 1,000 times 10 is 10,000. So there are 10,000 ways in which we could create our 4-digit ATM PIN code, wherein repetition of digit is allowed. So that's it for example number 3. It's fairly easy, right? So let's continue to our next example. For our example number 4, your ATM PIN code consists of 4 digits from 0 to 9. How many possible ways can you form your PIN such that repetition of digit is not allowed? So the only difference from question number 3, example number 3, is the word not. Okay, so let's proceed with the solution. So still we would let n is equal to the possible ways in which we could form our 4-digit ATM PIN code from numbers 0 to 9. Note that repetition is not allowed this time. So still, we have 4 vacant slots representing our digits of our PIN code. We have the first, the second, the third, and the fourth digit. And also, numbers from 0 to 9 consist of 10 numbers. So in our first digit, how many choices do we have? Correct. We have 10 choices in here, right? And how about in this second digit? Note, repetition not allowed. Okay? So let's say, for example, we have chosen 0 as our first digit. Then, how many choices do we have left? Correct. So there would only be 9 choices left. And for the third digit, since we already have chosen another number for the second digit, let's just say, for example, for simplicity, we choose the number 1 as our second digit. Then, for the third digit, we are left of 8 choices, right? And let's say, for example, we choose number 2 as our third digit. In our fourth digit, we are left of how many choices? 7. Correct. Okay. So simplifying, we have 10 times 9. That's 90. Right? And we have 8 times 7. That's 56. And 90 times 56, that would be 5,040. So we have 5,040 ways in which we could form our 4-digit ATM PIN code. This time, repetition of digit is not allowed. So in comparison with our third example, wherein repetition of digit is allowed, we have 10,000 ways. Okay, so that's it for our example number 4. So let's proceed to our 5th example. For our final example, how many possible arrangements can we arrange the letters A, B, C, D, E, and F? So still, we let n our number of possible ways. So how many letters are involved that we need to arrange? So that's 1, 2, 3, 4, 5, 6. So we put a blank here, 1, 2, 3, 4, 5, 6, and we multiply all of the possible ways. Okay, so in the first slot, we can choose from A to F. So we can choose among 6 letters, right? So 6 letters. And here, since we only have 6 letter, we pick already 1 letter here. So it follows that there will be 5 letters left. Then this will be 4, this will be 3, this will be 2, and this will be 1. So multiply. So that would be 6 times 5 is 30. 30 times 4, that's 120. 120 times 3, that's 360. 360 times 2, that would be 720. And 720 times 1 is still equal to 720. Okay. So there are 720 ways in which we could arrange the letters from A to F. So that's too many to list. Okay, I think that's it. I hope you learned something from our video tutorial. So stay tuned. Please like, share, and subscribe to my channel. And thank you so much for watching. And let's do something else on the next video. And we will discuss about permutations and combinations.